Just a bit of a quick intro. Thank obviously GRDC for funding this project. It's part of the new grain autonomy project. So GRDC is putting quite a bit of effort into looking at the pathways to farm automation, and that includes, not only just the on-farm activities like spraying and that kind of thing, but also the whole ecosystem around agriculture and how does agronomy fit in to that autonomy picture as well. The program's only just been launched pretty much last week, so we're one of the early projects to get started on this. So it's part of a much bigger program of robotics as well. There's a huge robotics component, and there's also components around weed detection, disease detection, and all sorts of technology that fits around that as well. You might have heard of things like BioScout, where they've got technology in fields to monitor for plant pathogens in the air, that kind of thing. So there's a massive program underway that includes this project. So we're one of the lucky ones to get started on that. Also, thanks to Neil for, I guess, basically allowing us to pick a field that's quite variable and look at how technology can sort of keep up with that and look at the changes as the crop grows. So I appreciate being exposed to the world of one of your paddocks, and Pete, who's coming shortly, to provide that sort of agronomy support. Anthony as well for allowing us to use the shed today, which is much appreciated. Morning, guys. Grab a burger and there's a burger over there, or a coffee as well. So yeah, appreciate this is a good venue. Well, it could have been raining, so it would have been a good venue. And of course, Roger, who's not here today, his property, we've cut up his tracks, so let's get out of here as quick as we can before he gets home. And then we don't have to worry. So hopefully we haven't cut up his tracks too much. So is there any questions at all on that program generally? Is there anything all good? What we'll do is we'll kick off. Tristan will give a bit of an overview of sort of things about where does autonomy fit in, and then I'll dive into what we've actually found on the paddock and what sort of tools we've been using.
No worries. Thanks, Tim. So this project, as Tim mentioned, is called the Autonomous Agronomist. Now, the aim of that is not to replace the agronomist, but simply to sort of do what, use machines for what they're good at and use humans for what they're good at. So it's, as Tim said, it's a GRDC funded trial. And it's sort of recognising that farm sizes have increased massively, skilled labour is decreasing, and then how are we going to achieve the your agronomic and production outcomes in that environment as that trend continues. And even just in a little snapshot of my life, like when I left the farm in the late 90s, Dad was running probably 2,500 acres, and I don't know what Spank's running now, but it's something ridiculous. I don't even think he knows what he's running, but it's much bigger than that. It's at least 5 times, or three or four times bigger than that, what he's running now. But he's not running it with many more humans than what Dad was running the farm back then. He's probably got 2 or 3 people at his core that are running that large show, and obviously he invents new hours of the day that most other people don't. But either way, like that's a trend that I've seen in my existence, and I think that's a trend more broadly where farm sizes have increased, doubled or tripled in some cases, and if you've ever tried to hire skilled labour, it's quite difficult. It's quite a competitive market to get those people on farm or in businesses. So can we automate agronomy in a way that increases agronomic efficiency, enables better interaction and communication between farmers, agronomists, and supports more timely and precise actions in the field? So autonomy cycles or targeting cycles is something that I'm very, very familiar with from my time previously in the military. And when I explain this project to one of my military mates, it's very easy for them to understand what we're doing here. And I think most of the farmers here would whether you recognise it or not, are actually in a cycle anyway. So there's the start of the year. You might sit down with the agronomist for the strategy meeting, which is otherwise known as a farm plan. You then go and book your resources that you're going to put into the field. Then you go and book your sprays and buy all that sort of equipment. It's a nice little cycle that happens the same way across the year. And the beauty of a cycle that happens the same way each year is that you don't necessarily have to put a heap of thought in it. You don't have to try and figure out new and wonderful things each year. You just basically incrementally improve on your cycle as you go across. And so that's what we're just trying to augment that with machines and computer vision and AI to sort of speed up that process. So what this project is the use of wide area persistent surveillance. So that's Tim and DataFarming's use of satellite data. Then, based on what we find in that broad snapshot surveillance, then we conduct some high intensity surveillance. So that's the docking station you can see out to my right there, equipped with a drone. We have received approval from the Civil Aviation Safety Authority to position that in a paddock, have area approval to then control that from a remote operating centre elsewhere. So that thing can sit in a paddock and basically do data collection every day if you want to, or every second day, or whatever cycle you want. Collecting the data is only one part of it, obviously. Then that system, and I think some of the stuff that Tim's doing as well, is paired with I'll say AI, but in our case it's computer vision technology that basically can look at the data, look at the images, refine what you're seeing in the images, and detect whatever it happens to be. And I'll give you some examples of what we've done over the last 4 or 5 years in that space to give you some context behind that. So wide area persistent surveillance, high intensity surveillance, so it's like going from an area of interest to like a targeted area of interest, really having a look at that. And then there's no point if you've got 1,000 of these docking stations out, then that having to come past me or Stephen or someone like that and having a look at everything. So we want to automate that. That's where the AI comes into the form. So that's detection, then prioritisation of what it's detected, aggregation of that data, and then the dissemination of that data to decision makers in a way that makes sense to them. So if they're getting an alert in their phone every 2 seconds, they're just going to tune out to that. So it's about prioritising that data so that it's received by the person that needs it in a timely fashion, and received in a way that they can not have cognitive overload but can make decisions on that in a timely and appropriate fashion. The next phase, we've got PYAG involved in this particular project. The next phase is the decision. So that decision obviously is the agronomist and the farmer working collaboratively together to decide what they're going to do about the issue that has come through the cycle. And then there's the execution, and I'll show you some examples of data that we've been able to execute using exact applies or using the spray drones. And obviously one of the areas we want to investigate here is other sort of autonomy, like the swarm farm style bots and whatever, not just drones and conventional spray rigs.
Tristan, you just want to mention Yata in that as well, where they fit?
Yeah, sorry, and there's one other partner here, and it fits into the detection, prioritisation, aggregation, dissemination. There's a large language model company, so thinking ChatGPT, but this particular case, it's a company called Yata that is utilising GRDC papers for all of the agronomic sort of intelligence that is pushed into it. And so the aim of that is to identify what the issues are, push that into a large language model, and then get preliminary decisions out the back of that. So obviously those decisions are based on good data from GRDC papers, rather than just like shooting it out to the web and taking a ChatGPT example, which sometimes makes stuff up. This will be based on the GRDC papers relevant to that particular issue. Did I cover that correctly, Tim? But have you that? Right. So how does this sort of fit in? And I'll speak primarily now from the drone perspective, because that's sort of what I'm fulfilling in this project. So in fallow, you might have weed detection, there might be feral pest monitoring, there might be maintenance monitoring, fire detection, stuff like that. Anything basically at the higher end using computer vision to detect weeds, and then pushing that into spray rigs or spray drones to target that. But then at a real practical level, like I'm just thinking, I like to use Spank as an example because he's got so many interesting things that he does on his farm. But one of his paddocks where he lambs, as an example, would be 35, 40 minutes away from where he lives. And so at that time in lambing, he's sort of hitting that road many times. In fact, I think he told me a story about rolling his ute there last year. And so that's a lot of time on the road. That's a lot of risk he's taking, particularly with the lack of sleep that he endures. And that might be something that could be solved. A very simple thing. We're not sort of talking about, cracking the atom. We're just talking about, hey, put the drone out of the box, have a look around, see if there's any ewes in distress. If there is, then get in the car and go for a drive, rather than going for a drive just in the off chance there's something going on there. So think about it from the high end of like, hey, we can detect individual species within a green crop, all the way down to, hey, did I shut that gate? I can't remember. Pop the drone up and have a look. Sowing, so we've done some emergence mapping here. I think Tim's going to go through the data that we've collected from Sandy Lane here in a minute, but certainly emergence is something that we can determine. You see the little map there on the bottom. That's the emergence that we analysed with the drone there, and I think Tim's got a broader scale of that. Early crop, and I'll take you through some examples of this, where there's green on green weed detection, pest detection, insect and disease detection that we'll be able to do with computer vision technology. And then late crop, change detection, disease detection and other anomalies. So anything that's sort of happening in the crop at the later stage. Some examples. This is just the example of some green on brown. Most people should be familiar with this. This can be done via drone or even on the boom with things like weedits and whatnot. Radish and canola, this is a local crop, actually, just a bit further towards Parks, and this was done, I think, 3 years ago, something like that. So one of our earlier green on green detections, that's radish and canola. Ryegrass and wheat, this was last year, I think. That was a particularly interesting one because ryegrass obviously and wheat look fairly similar, but we were able to differentiate between ryegrass and wheat in this instance. And the heat map on the left, as you look at it, is basically where the instances of ryegrass were in this crop. That's a crop near Dubbo. And in this,
there wouldn't be any ryegrass.
no, got it all sorted. Yeah. Yeah, well, if you've got a crop like mine, I was just trying to figure out on my little hobby farm whether I had an oat crop with ryegrass in it or a ryegrass crop with oats in it. But anyway, the cows are eating both, so we're good. And interestingly, in this case, the farmer chose an operational method to solve that problem, which was just baling the headlands and that little patch in the middle there, and then harvesting the rest of it, because he wasn't able to apply a chemical solution to that. And in this particular case, we were able to give him an exact number of ryegrass numbers in his paddock, which he wasn't too happy about. Next one, something we've been doing with PY Ag over the last couple of years is nightshade and other species in pasture. And we thought this was going to be a bit more difficult because pasture is such a complicated environment with like stumps and bushes and all sorts of species or whatever, but in this particular case, and you can talk to John about it in a bit more detail afterwards if you like, we're able to identify nightshade within that pasture environment under certain conditions. Another good green on green, it's just to sort of situate you of what the drone can do, because this is obviously another difficult one where you've got a rice crop with a invasive species in there, which is the same colour essentially, but it produces a different sort of shape and texture. We're able to identify that within a rice crop down the Riverina. It was 140 hectares, I think all the stats are there, but 140 odd hectares. They were going to hit that with a spray plane. We're able to detect that and then send in the drones, and they the instance of that weed was only, whatever it says there, 4.3 hectares of that paddock. So they're going to do 140 hectares worth of spraying. Instead, they just did 4.3, which is a better result for them. Again, another rice example, barnyard grass. Shows you sort of complexity. So the same colour, barnyard grass, basically the same colour as rice there, but the structure, we were able to detect that with computer vision technology and produce a solution for that. And that's a fairly old one too. When was that, Stephen? That was like three years ago, something like that. So the quality of the imagery has improved since then. Where we're wanting to go though, and we're still working on this, is detection of anomalies. So this is data that we collected, I think with PY Ag, probably over near Forbes there 2 or 3 years ago now, and ran this through. It's a different system to what we're using now, but it's a good example of where we're trying to get to with detection of insects and pests. So if Tim's satellite service picks up that there's an issue going on in a crop, then we can send the drone and get these sorts of images. And we're not talking about sort of 2 or 3 images, we're talking about hundreds of images across a paddock, put them through a computer vision system. It then drops out the ones that have anomalies in them, be they bugs, you can see there's a blemish on the leaf there, some sort of disease there, or even weeds. Push that out, heat map the paddock so you can understand what the pressure that you've got within your crop is. So that's, there's systems out there that are capable of doing that. The current system we're using probably doesn't get the same level of resolution as this, because this was a full frame, like photography camera slung below a drone, travelling at about 14 metres above the crop at about 40 k's an hour, taking those sort of images. But yeah, that's an example of where we're heading with this. So, so there we go. That's basically my part of the presentation. So what we're doing is just trying to make you're already in a cycle, you're already in a cropping cycle. We're just trying to add to that cycle, so you don't have to think about it, but you can get across the areas that you're going to have to get across if you're going to be successful farmers into the future with more land, less humans, in a way that makes sense, so you can keep your margins profitable, your farming profitable, utilising drones and AI for what they're good for, and then your decision makers, agronomists and farmers, for what they're good at, and that's making the decisions based on data that's accurately collected and prioritised and disseminated to you in a way that you can make decisions. Are there any questions on that? And after this, when we're finished here, you can go around and poke around and have a look at the docking station. That's just one example of a docking station. There's a variety of different ones out in on the market, including DJI's got this little dock that we can also utilise. The main issue with that system, though, is the legislative stuff that we have to go through to get that set up. So we've been through that, and we've got an instrument from CASA to have that thing, parked in a paddock sort of near Peak Hill there. And we're going through that process now for Sandy Lane, but interestingly, that process hasn't concluded for Sandy Lane yet. We've been going for a fair while, and that's actually not a bad outcome to have it not approved for us, because it sort of gives us an ability to say, well, what's holding this technology back? The hardware is pretty much there. We've got hardware examples that we can use, and there's docking stations, there's all that stuff. Connectivity's there. We've got, that thing's got a Starlink on it and an alternate internet modem on it as well. The AI, that's getting there. Like, we've been proving that for the last 5 or 6 years, that we can detect heaps of stuff, in crops right now. Then legislatively, we're probably not quite there. So if one of you guys say, yep, I loved your presentation, I'm all in, let's put one in my paddock tomorrow, it'd probably still at this point take 6 months to get that approved. And I think that's not really, that's not the situation we want to be in with technology, where hardware, software, connectivity is all sorted, and it's just the government that's slowing us down. So that's it's not a bad outcome that it hasn't been approved yet for Sandy Lane. We know that it can be approved. It's approved on Spanks Farm over there near Peak Hill, ready to go autonomously. But we haven't been able to achieve that yet for Sandy Lane, which is not a bad outcome, because it gives us some leverage with, rather than Tristan from StevTech trying to approach CASA, we might be able to utilise something like GRDC and other government bodies to sort of say, well, hey, we need to get this sorted so we can do this sort of stuff quickly and efficiently to improve the efficiency of Australian farming. Any questions on any of that? Technical stuff, hardware, software, legislatively?
What kind of hectares could you cover in a day with that, Tristan, in a cropping scenario for early wheat and canola checks?
So for that sort of insects and pests and whatever else, the way we're aiming to do that is by scouting. So as an agronomist, you would go in and you'd check those parts that might be the issues or whatever. The way we would do it would be just to grid pattern that whole paddock. And so the number of hectares would then be based on what sort of level of surety you want as an agronomist in that paddock. So do you want 10 photos per hectare? Do you want 5? Do you want 30? Do you want 1,000 per hectare? And that'll determine. But the beauty of having it positioned there the whole time is you don't have to call me up. I don't have to get James out of bed, get him over there. Oh, it's raining. Come back the next day or whatever. All the issues that are an issue with drone services right now. most of those go away because it can just sit there in the paddock and collect it every single day. Yeah, and that's the idea of having a completely hands-off collection and analysis phase is probably what will make this easier to integrate into farming, in that you don't have to get a contractor on, you don't have to worry about someone looking at data or whatever. It just goes to the cloud, gets processed through a computer vision thing, comes back as a prioritised map, and you know what you're looking at then. So the number, I haven't answered your question because the number of hectares depends on a bunch of variables, but as an example, that thing is authorised to fly 6 kilometre radius, so 12 kilometre diameter area. So, and for spot checking, it's not that hard for it to do at that distance. For doing large mapping missions where you've got to get the whole like a weed detection thing for a spray rig, that will be a bit more difficult at 10 k's. But detection of pests like that wouldn't be that difficult. Yeah.
What about the plant population for canola?
Yep. So we've done a lot of that with. We've done a lot with PY Ag with corn, and we've done some stuff with cotton as well. And again, that comes down to how much surety you want. So we can map the whole paddock and count every individual cotton plant, and that's an expensive, time-consuming thing just from the data perspective. Or then some of the work we've been doing with PY Ag is like sampling again. So you just sample all these different locations, and then you aggregate it. Like, so basically you have individual numerical values for each of those samples, and then you just merge them together into a heat map. Yeah. So we can do that. Yeah.
So what about, so it seems that the main aim of this is to replace manpower with intelligence, I guess, like as in the limited availability of blokes with brains. The other thing that we have in agriculture is the limited availability of money. So is there a sweet spot here, or is this at the moment too far away to be cost saving, or to save money on the existing production system?
Yeah. So of course I'm going to say no, we're right to go right now, Bob. But everyone's situation varies, and everyone, like, it depends on a heap of variables. So if you could replace like a full-time, person with this to be able to go and check things, and it would make total sense. I guess it's variable. Like if you're in a high-value cropping area, it's easier to make those dollars meet. But if you're struggling to get across your land anyway, and there's things that you're missing because of that, then that's a decision only you can make when you see the figures, I suppose. Yeah.
So to round that question up, is there a cost per hectare, or is it's variable as well?
Yeah, so there'll be the model that we're going to use, and we haven't firmed it down yet because we're still just sort of running this as a trial project with GRDC. But the model that we will probably run with is a hardware leasing plus pay-as-you-go data thing. So data package, I should say, and that way you might only want a dock in place for a particular part of your season. Like you think, right, this is my high risk. If, like, let's say you're a canola grower down south and you got an issue with grubs or something like that, it's like I need, I can't get across that whole, or across that whole cropping endeavour in that particular window, then I'll just take 3 months of the docking station and that style of thing. Or you might say, well, I want it all year round because I want to monitor feral incursions of pigs at the same time as doing fallow weed detection, at the same time as doing emergence mapping and all that sort of stuff. It just really depends on. And the idea of leasing is that, so if you wanted to, Bob here, dryland cropping, wants to go for a cereal season, and then we might go down to Forbes or Dubbo or something like that for, a summer cropping season. So we can bring that out of your place, do the, quick little maintenance sort of routine on it, punch it into the next season, then you get it back, like that's why the leasing versus, we'd be happy to sell it to farmers, but I think it's probably going to be more palatable to have a leasing plus pay-as-you-go data sort of process initially, so you know what you're going to be outlaying and how it works.
Surely though, just for the likes of Mark, John and Luke and agronomists to have something parked here that does a 6 kilometre radius, picks up multiple farm enterprises.
Yeah.
That's where they say, they can, instead of hopping on their quad in the middle of winter and freezing their butts off every day, they can check things from the comfort of their gas heated office. it's going to be a little bit more attractive.
I think that I think agronomist is one of the key markets for us for sure. How that works within their business model probably up to them and their farming groups. But if you think about it, like you think Peter Yellen that runs PY Ag, I don't know how many customers he's got, but he he probably has, let's say, he has the same amount of customers he had in like the early 2000s that he has now. He will have twice the land or 3 times the land, even with the same amount of customers. So if he's got more customers, he's got a huge issue he's got to deal with by employing blokes like John and whatever. And John, how much time do you reckon you would spend in the car versus checking a crop? Yeah, I reckon that the ratio of car time versus like agronomy work would be quite high, whereas this allows him to invert that ratio to being, QAing stuff that's come from a robotic autonomous system, QAing that using his agronomic experience and qualification versus just sitting in a car and opening gates for 2/3 of his time or whatever it happens to be. So it means that agronomy businesses will be able to invert their cost effectiveness of running because their agronomists will be doing agronomy more than they'll be doing travel. Yeah.
Do you think some of the economics is about being able to respond to what you know? And that's an age-old question with agronomy, whether the agronomy was coming from out of someone's house or coming off a drone.
Yeah, I personally think that's like coming from my background in the military. You can only do what you know is happening, and so that's a huge thing. But I think also, if you think about the farmers of the future, like I think that there'll be more of an appetite to run a farming operation like a farming simulator. In some ways, so they will, if they're on farming gaming and that sort of stuff, they'll be expecting certain inputs, and they can replicate that using these sorts of systems to be able to then make decisions on data. Because a lot of decisions in farming are made using heuristics, using stuff that you've learnt over a lot of time, and some of them might not be necessarily accurate. It gets the job done, but it might not be accurate. This gives you that data to make those decisions on. Yeah, and I think as we're going into like paddock to plating and sort of traceability and all that sort of stuff, this sort of stuff will provide you real time data on, okay, how much spray did we put into that paddock? Well, we know that it was like 4 hectares out of that 140, which is a great thing for traceability. Saying, well, we're not just blanketing everything. We're using computer vision technology to detect where the weeds are, precisely apply it, and we've now recorded that. That's now recorded as part of our whole system, so that if anyone comes back and say, well, yep, for the last 10 years we've been doing this, the rules have changed now, but look how we've complied with them before they were even in existence. So yeah, I think data in every environment is becoming more and more important. And this is one way of just collating and collecting and retaining that information for your own purposes. John?
Yeah, Tristan, I guess for everyone here as well, but whole drone stuff, what we've found is that it's a no size fits all. I guess if you can visually see a problem in the paddock, then chances are these drones and these cameras on these drones, they're only getting better. So, if you can visually see the problem, then chances are you can create a prescription map very easily with these drones, and that probably ranges from, even making if you've got a spot sprayer or a camera sprayer in summertime, making a decision to spray a paddock, then, a quick flight with one of these might help with that decision. But, that's going to be these drones, depending on the height they can fly or the picture they've got to pick up, it varies in the cost there. So I guess to make a call on a fallow spray, that's going to be your cheapest and most efficient way of flying a paddock versus, if you want to pick up a 2-leaf corn or sorghum plant or cotton plant or canola plant and do crop counts to, help you make a decision on whether you've got to replant a paddock. That's the more, I guess, higher pixelated images, so it's going to cost you more. You want to be flying low, you want to be getting a better picture, and I guess it's probably sold them, but you can basically do anything from that to your fallow spraying decisions as well. And I guess if you can come up with the problem, chances are the drones might be able to help in some way to find a solution.
That's too.
How do we manage all the data? Like, is there another platform? Like, that's what I struggle with all this stuff, is that we've got My John Deere, we've got AgWorld, we've got PCT, we've got all these different platforms that is gathering data. How do we get all the data together into one spot? Like, with all this, we're going to be not bombarded, but we've got another Dropbox folder full of data. How do you guys see we manage that? Because especially as I get older and cynical, how do I
Manage all that, yeah.
manage all that,
Yeah.
that's what-
Everyone's got another platform they want you to go onto. Yeah, no, agreed. And that I think is one of the things that we want to explore with this project, because there is no answer that's going to fit everyone, I don't think. And you're right, there's going to be a lot of data collected here. The aim of what we're doing in this particular thing, though, is to make sure that the data that actually gets to the end user has to make a decision on it, it doesn't cloud their decision making. So, like you said, if you're getting 55,000 email alerts a day, you're going to switch off from that immediately. So that's one of the challenges we'll have to wrestle with in this project. And I think is one of the reasons GRDC sort of funded it, is to just to get into the understand how this fits in a cycle without creating another thing, because you've got
Like
enough things.
Ben touched on before, if we're madly running around doing canola population checks and we know,
Yep.
we've seen that this has gathered a 3 hectare area that's got slug problems.
Yep.
If then we check that ground truth that, yeah, slug, did it get baited or not? Because it's still giving us alert 2 days later that it's got a lower plant population. Like being able to get all that data,
Yeah.
actuals really quickly, I think it's all part of this, isn't it? Because otherwise we just create, without being cynical, saying it's creating a
Yeah.
job, it's
Yep.
going to be, I suppose, streamlined, doesn't it?
100%, yeah, and that. I mean, we haven't got this solution in train. This is sort of more thinking how I would see it happening. Like, I would see that like say, you're an agronomist, you'd have like however many customers, let's say 10 customers, 20 customers or whatever. Each of them have got a docking station, each of them have got, satellite monitoring, all that sort of stuff happening. That happens throughout the week, and all that information goes to the cloud, gets analysed and then gets prioritised and then gets sent back to you. So Monday morning over your Kellogg's or whatever, you'll see that, hey, paddock 1 in Bob's place is like priority 1 because it's got this, that and something else going on. And then you would make the decision, well, do I send someone to priority 1, or actually, in my mind, because of everything I know about priority 5, that's actually priority 5. But either way, you've got it in a prioritised list so that you can then, deploy your manpower to where it needs to go in the quickest possible way, in a way that doesn't sort of interfere with your ability to react to things. So if you get emails or text messages or whatever every 5 minutes, you'll shut them off. You'll just, that's aggregating it into a cycle, and it's all about cycles for me. So aggregating into a cycle that you know when to expect a thing and what decisions you have to make off the back of it. Yeah. But that's just me imagining the future. We're certainly not there at the moment.
No, it's good though, because like you touched on with Monkey, like we spend 3/4 of our time in the car.
Yeah.
It's highly unproductive.
Yep.
Trying to get that data quicker and
Yeah.
accurately is key. Isn't it?
Yeah, and that's what is sometimes referred to as human-machine teaming. So just using the machine for what the machine's good for, using the human for what the human's good for. You guys spend a lot of time in university and a lot of time in paddocks developing, your expertise. You shouldn't be spending the whole time in a car. But as your customer base expands and gets larger, you spend more and more time in the car. So yeah.
So the 12K rate, that's set by CASA, is that
That's right. Yeah. So that's like.
for that to expand,
Oh, 100%. That's all hardware based. So what that is with CASA is 80% of the maximum distance per the manual. So if you put something with with a longer time of flight, then it becomes longer. You could put a VTOL fixed wing with 2.5 hours time of flight and do the district in a flight. That's just a hardware issue. Yeah.
It's to do with the radio
Comms as well. Yeah. So yeah, with CASA, it's like what the equipment can do, basically the drone, and then also what the communication systems can do to make sure that you've got redundant communications in case something goes wrong, like you come across a crop duster or whatever.
Yeah, I just, if your agronomist is based in Forbes, he's got to come valley, there's 45 minutes in the car. He's got 4 clients in this area, and they're over a 25 play radius.
Yeah.
Radius.
I'm picking up on a theme here for the agronomy people, is that they want you guys to buy the drones in blocks and put them on their place.
We get charged a parking spot too, but
Yeah, that's right. I might hand over to Tim now to just describe what's been going on out in just a bit further to the north here. Thanks, Tim.
that's good.
Yeah, cheers.
Just to follow on from that question you had, there's a thing called APIs in software programming. It's basically computer to computer speak, essentially. So data from AgWorld or the data from my software can go into AgWorld or vice versa. Currently it's not happening that much, but in my case, my software, I feed data to 6 other software companies already. So that's the current way of doing things. The problem with that is it's not cheap to build those things. And so customers are asking for it, but who's paying for it? So we're still in this, we need to share data and we need to sort of aggregate it, but then it's another cost. And so that's why AgWorld really hasn't done much of it at all either. It's another burden. But there is companies like Peartree who we work with. Their whole job is to pull everyone's data and put it into one dashboard. So he's got over 100 integrations now with 100 different software programs and pulls them all into one place. So that's why I think it's actually pretty good business really, because if someone drops off, he's still got a customer. So he's got all these customers feeding data in. So I think this will eventually sort itself out. But the thing in agriculture is that there's no standard. Unlike the banking sector where you can pay between banks within a few hours, most times, the problem in ag, we've got no standard. So everyone's doing whatever they feel like, and John Deere's doing their bit, and they're sort of now setting the standard because they were just the first to open up. So that's a bit of our problem, and no one's put up their hand to say they're going to do that. There is also some projects underway. One's called the Australian Agricultural Data Exchange. It's being run by Food Agility at the moment to actually pull all data into one spot. But yet it still hasn't got the buy-in of all the companies, the 100 companies. So there's actually 600 agtech businesses in Australia, would you believe? 600. So how do we get all that data into one spot to help you make better decisions on the day? That's the challenge. I guess a quick background, DataFarming, I've formed 7 years ago, basically with this frustration that all this data existed but no one was using it. So we've said, well, let's go to a mass market approach. How do we get this data out? And it's stuff I've been doing for 25 years. I've been working with yield data and EM for 25 years. How do I get this stuff that works really well into the everyday farmer and agronomist? So to the point now, we've got about 45,000 farms on the platform globally. Most of those are in Australia, of course, but we're starting to see big expansion outside of Australia. So, I think our model's worked about getting people actually looking at data and making decisions on it. Now, what's the next step? So that's a bit of a background about data farming. So I'm just going to jump through some of the things we've already found on this one paddock. And the way we didn't actually explain how we got here, mate. But in reality, so we saw this need to help agronomists cover more ground. We've got about 500 agronomists using our software platform, and I could see this thing that they really want the next step. How do I actually help point me in the right direction every day where I should go? Exactly what you said before. And of course, I've known Tristan for quite some time, and he said, well, I've got this new drone in a box. I knew it had to couple with drones. We needed an on-farm, that connection to the farm at high resolution. And so that's why we ended up down here. So it's a long way from Toowoomba, but it's been a good partnership to try and test this technology out and see if we can integrate these technologies together to actually deliver what we're actually trying to achieve. So the first thing we're able to get is super high accuracy elevation data over that property. That's freely available from the government, by the way. So the government's collected this on your behalf. You probably don't even know about it because no one's told you, and no one's told you how to access it. So here you can see very clearly the highest point of the field up the far right there, and the lowest point down here. So, like some of this data might not be suitable for all paddocks, but if you're going to do farm layout planning on this, for example, if you're going to do drainage designs, that super high accuracy elevation data exists, or you can pull it off one of these machines. If you've got RTK, then you're getting also high accuracy elevation data as you're driving across the paddock. So we haven't used this much yet, but at least it points you in a direction of where the frost might be, for example, where water's going to drain, where you might have waterlogging problems. So go back to Tristan's anomaly detection. If I'm going to find anomalies in this field, I'm going to need this layer to help with understanding things like waterlogging. We then, I've got a device that I've created called a Rapid EM. Is anyone familiar with EM, electromagnetic technology? a few. So what EM is it's a really new technology. It's been around since 1950. So it's, you know, it's not new. It's been around forever. But what we've done is put into a box. It measures down 1.5 metres into the soil profile, and it's picking up differences between the sand, silt, clay, and also moisture, and also chloride, so any sort of salts in the profile. What we've done, we've got 6 of these things running across Australia now. I'm sick of doing EM. I've done heaps of years driving up and down paddocks doing EM. I thought, this is crazy. There's about 4 suppliers in Australia that can do EM. So how do we get this democratised? How do we get it out to the mass market? So basically you can hire these now from us. You put it on the back of the ute, you can drive it yourself, the data gets processed and pushed to the cloud, and you don't have to do any data sticks and all the crap that goes on with EM mapping. This can be done by anyone. Just hit logging, stop logging, and you've got yourself a map. Is there any questions on that at all before I move on? I'll show you the maps in a minute, what we created from the paddock. Depends on your country. If I'm going to central Queensland with 2,000 acre paddocks, I'll probably push 35, 40 metres. If I'm in Melonhole country in the back of Tara, I might 10 metres. But for most farming, 36 metres is fine, just keep out of the wheel tracks. We also did a little, I got some local guys to build a little prototype weather station. Because I'm a tight ass, so I thought, well, I've got to get something a bit cheaper for the site. These guys knocked this up. Really interesting tech. This little box here is the full control box. I haven't seen anything like it. That's why I wanted these guys to have a play around with it. Obviously, wind speed, temperature, humidity, rainfall, and it's got its own little tiny solar panel. It works off NB-IoT, Telstra's new NB-IoT network, which has got 100% coverage across cropping lands. And again, Telstra doesn't tell anyone about this stuff, but everyone's trying to use 4G. Ridiculous. Absolute waste of time. There's so many people using 4G, and now 3G is getting turned off. This NB-IoT is built for IoT devices, Internet of Things devices, like weather stations, like rain gauges, like moisture probes. And everyone's still building on 4G. So I got these guys to knock this up for me very cost effectively. And I think we need to see more of these low cost sensors deployed widely. Like, I get why there's a $5,000 weather station, but we can't have one weather station every 10 kilometres. Our environment's so variable, we need more sensors in the field, low cost sensors, to help bring all this data, to help you make better decisions. Oh, he knocked that up for me for like $1,500. But now he's decided to go off and do other things. So I think we need to, it's the chicken and egg scenario, right? We need to get more sales for him to get volume. But, you know.
Running cost for the data, like what's the...
Nothing. The NB-IoT is like a smidgen of the cost of 4G. Because it's only just doing data packets. It doesn't do voice. It doesn't do it. It just does data. And it's very small packets of data. So it's a lot cheaper to run as well. And again, if we want more sensors in fields, we've got to make them really low cost. So we can put lots more of them. But no one seemed to have worked that out. We end up with still buying $5,000 weather stations. So, yeah. That's just my soapbox. So yeah, it's been collecting data. It's been good for me. I can see when you've had some rain, normal weather station stuff. But again, getting back to your point, you don't want to see this. This is the last thing that a farmer wants to see. You don't want to see wobbly graphs. You want to see how much rain I get, what have I got to do about it? Jumping across to the EM. So the EM, you can see where I've driven in the paddock. I didn't do this end, I ran out of time, sorry. I only got this end of the paddock done, I had a very short window left. But this is at 0 to 50 centimetres, so it actually measures 2 different depths, 0 to 50 and 0 to 100, or 1.5 technically. So it's measuring 2 depths. They look pretty much the same in this paddock. But what do you notice about this? The red. Can you see the red? Yeah. It's the old wash lines, the old sandy river runs. And if you farm that paddock for a while, you know where they are.
Don't make much money.
100%. So they cost you money, don't they? Because that's where all the weeds come up first. You get the lowest yield. So it's a double whammy. But it's really nice for picking up those sand, silt, clay differences in that paddock. If I go to you notice the 1 metre one is really no different. So those sandy patches are snaking through that paddock. Obviously that's the actual raw point information. What we do then is interpolate between the points so that you can get a whole sort of map of that, but that's just the raw data.
That raw data that it's just the sand is the problem, or is the sand more acidic, or you just, how are you going to use that data and make more money?
Good question. So let's go to the next step. So the other thing we did, there's another tool we got here. So go back to satellites now. So this particular satellite imagery has been around for 7 years. So we stacked all 7 years together, and this is the long-term productivity of that field. So these sandy areas are sticking out here. That's a bit of a creek line, so don't worry too much about that. The highest productivity over the last 7 years is here and here. And so that there, when we looked at it, and you can do this on our software now, we just charge $99 a paddock to do that. So you can do however big the paddock is, I don't care. But if you trying to do 3 paddocks into one, it doesn't really work. But that there is a shapefile which can be put straight into a variable rate spreader. But you need to know what's going on. So we took some soil tests in there. And of course, as you point out, it's acidity. So the low zone, sorry, I haven't got the labels on those, zone 1, zone 3, zone 5. So let's go back a step. There's 5 different zones in that field, 1 to 5, lowest to the highest. So I took samples in zone 1, zone 3 and zone 5, so low, medium, high. Look at the pH, it goes from 4.2 to 5.5. Right? So next season, we'll go and throw, 2 tonne of lime in here, maybe 1 tonne of lime in the zone number 2, and nothing on the rest of it. Let's look at organic carbon, 0.75 to nearly 2. 250% variability between the high and the low zone in organic carbon. And that's all just based off the satellite map so far. But you could have done this off the EM as well, right? So the EM's picking up the sands, the acid sands, just turn that straight into a variable rate map based off this information. I don't need to do any more intensity than that. I just did 3 surface samples again because I was running out of time. But if you're going to do a carbon project of all these carbon cowboys running around, right, there's heaps of them. If you don't understand the variability in your field, you're not one of them, are you? No, I'm not going to get into trouble here. Oh shit, this is being recorded too, by the way. I better be careful. Like if they come onto your farm and don't understand that, and in year 1 they sample this area, and then in year 2 they sample this area, and they say, sorry mate, your carbon's dropped, you have to pay all your money back. Good luck with that. So this is what annoys me, is we've got to actually really understand the variability in our fields. That's in a small paddock up the road, 250% variability in soil carbon. Look at coal oil P. There's tons of coal oil P in there, but it goes from 75 to nearly 100, 75 to 95. So again, you've got plenty of phosphate there, but there's a variability. So, you've got to manage that as well. So you can, again, turn that basic zone map into a phosphate prescription map.
I'm surprised it's not reversed, actually, the coal will clear.
You've just put a lot of manure on some years ago, so it's, well, that's probably what it is, right? It's probably the one end that's where that heavy rates went on.
Oh, like zone 1 is very acidic. The whole feature of the show it down.
Could be bound up, yeah. So you do PBIs as well.
And just for transparency, there is a carbon project across there.
There is a carbon project across there as well, yeah. But, you know, again, if you're trying to measure very small differences in soil carbon, right, which is what we're going to achieve probably in our dryland cropping environments, only small jumps. We've got this massive underlying variability sitting in there that we need to appreciate. Fair comment? Any questions on that? So the next thing we did then is during the fallow, we took super high resolution satellite image. So we're now getting satellite data down to 30 centimetre pixels. So what's that? Size of your boot? Something like that on the ground. 30 centimetres by 30 centimetres. The data that I showed you back here, that's 7 years of data. That's 10 metres by 10 metres. So quite big. So we're talking 900 more pixels per, 900 times more pixels. 900 times more pixels. So then I said to Tristan, mate, we've got to get that drone up. So we just gave him those points to fly the drone and say, well, let's ground truth what we're seeing in the satellite image. Again, that map there could have easily been spun around into a variable rate spot spraying map. Easily. And what? 60, 70% of that field didn't probably need spraying. And that's not really super high resolution like Tristan's talking about, but we found some interesting artifacts in the satellite, in the drone photos, which my team like, what on earth is going on? Because I've got, no, he's got a, don't you have a rifle on your drone? A drone with a rifle, that's what we need. So we worked out that the roos are 30 centimetres as big as the weeds. So, you know, again, not, how high flying height was that, Tristan? Yeah. It was the first, yeah, so it's probably like 30 or 40 metres. Well, the roos weren't phased anyway by a big drone flying over top of them. So, you know, get to the point where we can keep zooming in to actually get weed ID. And I think the next step, once we get, you know, really good cameras on these things, is to then feed that data into a detection model that will detect, you know, use, I won't use the term AI, but machine learning to pick up what type of weed that is. So again, you can do weed type detection combined with the satellite. So, you know, the satellite here is giving you scale, I'm doing 10,000 hectares captures at a time, or 2,500 to 10,000 hectare captures at a time. And they can get that like that because it's flying past at 700 kilometres an hour. So I can get massive capture areas and then go, righto, I need these points checked. And so I think the mix between docking stations and non-operated drones and satellites is where the future is. We've got to mix the two technologies together. And that's I think, the really exciting piece of that. We're doing another project for GRDC to actually do the same kind of things that Tristan's talking about, but from satellite only. It's part of a 4-year project. We're doing weed detection from satellite, green on brown, green on green, and disease detection. We've got 4-year projects looking at that specifically. It's separate to this project, but I thought I'd mention it. We're, again, using 30 centimetre resolution satellites. And next year, what's something that's, is that 10 cent? No, that's not 10 centimetres. 4 inches. So the next year we'll have pixels this big, 10 centimetres by 10 centimetres from satellite. It's insane. Those things are about, what, 500 kilometres above the Earth? Like, that's just mind-boggling. So next year, I've signed a deal with a company, they will give me 10 centimetre resolution. And they said, what's that? No more taking a leak outside. I've actually picked up farmers in high resolution imagery. You see 2 utes parked up and they're having a yarn. Like, it's like, what are you blokes doing? And, so yeah, it's pretty scary what's coming, and there's no privacy restrictions. So you've got no control over that anymore. US government used to control satellite imagery captures, but now every country on Earth is launching these kind of satellites. So nothing will be hidden. You will be photographed from space. There's no choice about that.
What's the turnaround, Tim, time-wise, from getting that imagery and putting it into a section control on a boom sprayer or an individual nozzle control?
Yeah, we got really excited the other day when we ordered an image one day, they captured it the next day, and we got it the day after. I thought, that's very good. That's some of the best I've ever had in 20 years. This company with 10 centimetres, they said, how quickly do you want the data? I said, look, 24 to 48 hours would be fine. So we can process it quickly and get it onto the rig. Oh, they said, no, it's no problem. We'll give it to you in 30 minutes. Maybe an hour. I said, that should be okay. So, you know, like this is the level of tech that's coming. And to give you a bit of an idea on satellite numbers, in the last 2 years, we've doubled satellite numbers in space, doubled, and we've been launching satellites since 1960. 60 years, and it's doubled in 2. So the technology that's there and the speed, and the key thing is we've got to get rid of the humans out of it, as we've said before. If it's automatically downloaded, it's automatically stored, it's automatically processed and then delivered to you, then it gets rid of all this. It slows, people just slow everything down. And I think we can get to the point where this is you know, 24 to 48 hours will be absolutely on the money. The biggest problem we've got with satellite is obviously cloud cover. But these companies we're talking to as well, they're talking, we don't capture one image a day, we'll capture it every few hours if you want. Like, that's just mind-boggling, how they can capture multiple times a day. So the chances of getting through cloud, a cloud-free part, is just increasing. We also have other technology that will penetrate through clouds. We're using data in Malaysia at the moment that is penetrating through clouds, and we're counting all palm trees with the cloud cover of everything. So it's an active sensor. So it pushes out microwave beams through the atmosphere. So don't stand outside for too long, you get fried. But no, seriously, it is putting out microwave energy and measures the structure of the plants on the ground through cloud cover. Because in Malaysia, I get one image every 6 months at best. So now this tech is only going to improve. You've probably all seen this before, but so this is that paddock, some big old nasty feather top that's had 3 hits already, hasn't died. You see the section just come on then. So we're just taking that file, the yellow dots are now green dots on the screen. It just automatically turns that section on, and you know, 75, 80% reduction in herbicide just from that detection and spraying. We're still at fairly big weeds at the moment. We're still working on the algorithms, but we're only going to improve that as time goes on. So we get higher accuracy, smaller weeds, and the good thing is this is existing tech. We pushed this to the screen through my John Deere. I didn't even have a data stick. We've got it pushed through. The operator turned up, opened up the file, and we went spraying. No additional capex on behalf of that grower at all. It's all section control, just like that machine is.
When we get out to like Trundle in the good country where we've got some decent stubbles, how does that go with, say, that imagery going back to that original where that south thistle was taken?
Yeah, well, it's like anything. If it's shaded by something else, you're not going to see it. But we've hopefully got better, you know, vision from above is going to help a bit as well, I think, rather than on an angle. But But yeah, it's still going to be a problem if stubble's shading something. Well, if you can't see it, you can't see it. So yeah, there's still a bit more work to do on that. We're trying to do some work in sorghum stubble at the moment, and it's proving quite difficult. But you know, again, looking down from above, things look completely different to what you are on the ground. So, like I'm in wheat paddocks that look pretty heavily stubbled. You look at the satellite image from above and you think there's bugger all stubble there, but your eyes think there's lots there. So looking from above helps, doesn't it, Tristan? You know, even with drone data, you see the same thing. So there's a bit more work to do, but yeah, very excited that this is sort of technology that can be exposed to large numbers of growers very quickly. Yeah, with no capex. Any other questions on that? I'll jump back to Sandy Lane. So that's a little bit grainy, that image, but this was the establishment map. So after the crop came up, we took this as a 10 metre by 10 metre pixel image. We then took away the image at sowing time. So that is the actual establishment map from satellite. And then I said to Tristan, well, we need some points done. And you can see, you know, obviously the tines have gone in a bit deeper in the sandier soils. Is that a fair assumption? I can see that from satellite. There's a lot less plants, a lot less density compared to over here, where you can see that lot more growth. So I was actually quite surprised that the satellite at 10 metre pixels is actually that sensitive, but it's picking up really well that establishment map. And you know, the 10 metre satellite data is basically free. I provide it free. So, you know, trying to use existing low-cost solutions to help when you're doing crop checking. So yeah, I was pleasantly surprised. Is there anything else you want to add on that? Any other questions on establishment? So this is what it looks like a couple of days ago, again from 10 metre, and I've deliberately, my software deliberately stretches out the differences to try and pull out the good and the bad. So when I had a quick look yesterday, you know, this is a pretty good crop in here still. It's just the worst part of the field. So I deliberately make it look bad, no offence, but I'm trying to stretch the differences, right? I'm trying to make it as big a difference as possible, because I need to help you to say, where do I got to go? Where's going good? What's not so good? So again, I can convert this into a vertebrate prescription map in about 1.5 minutes. And you could be spreading nitrogen, could be doing whatever you see on the ground, you could be doing that in an instant. Again, you ask, how do we make money out of this? This is how you make money out of it. When we look back, let's go back a step now and say, what does the EM look like? You'll see that there's some quite good similarities between those two. But then there's spots like this. So that's not a sandy soil problem. Is it wet, is it? So this is why, again, we're talking about anomalies. So if you look at the long-term growth of that area, it's actually pretty good. So we're saying, let's also look for things that don't look normal. We don't want to just know where it's good or bad. We want to know this has always been bad, that's fine. We understand it's always bad. But this area has been always good, and now it's bad. We need alarm bells. So the next part of our project is looking at long-term crop growth. What's the variability in that? So how variable, this is not the same paddock, this is a different paddock. How variable has that been over the last 7 years? And then what's not normal? So my team are working on this. I've got a team of data science people working on this at the moment, trying to pick up areas that aren't normal. So not just good or bad, what's not behaving like it should. And you know, slugs are a good example, or disease outbreaks, or whatever. Waterlogging should come up as a highly variable thing, because in a dry year it's the best part of the paddock. In a good year, it's the worst part of the paddock. So you're going to see this high variability, like this here. That's probably waterlogging as well. So then looking at the differences between that, what you expect, and what it's doing this year, if that makes sense. That's also part of this project. If you want to keep updated on this project and all the others that we're working on, you can scan that with your phone, and just a little quick survey will keep you updated on how things go. But is there any other questions or discussion about what we've covered?
Just going back to the economics, I guess put up an example, like a lot of experience doing cotton agronomy.
Yep.
And plant establishment in cotton agronomy, we know that plant establishment is a big economic driver, but we're always busted for time to go out and do plant counts. So we're making decisions about replanting, you have crusting soils and all sorts of issues. Making replanting decisions on very thin data
Yes.
about numbers of plants. And the example you showed was, a great example of having more information. But not only about the decision on the day, the benchmarks that we were using for plant counts and crop response from plant density, they were all coming from WeWar or something. The data had been gathered at the research station at WeWar.
Yes.
Whereas if we'd had data from our own farms for a number of years, like we didn't really know what the crop last year that yielded 10 bales per hectare or whatever back in the day.
Yeah.
We didn't know
What the plant count was.
actually was on
Yeah.
that. So if we'd had that sort of database of what our own experience was and what our own response was, it would have informed our decisions about our replanting decision on the day.
Yep.
With much better confidence, I think.
That's
And I
100%.
think that's the thing. It's not about substituting the existing agronomist. It's about extending the agronomist and giving them superpowers to
Yep.
see in more areas more often.
Yep. And that flows through to things like soil testing as well. So I've been talking to Chris Dowling for about 10 years about this concept of every paddock should have its own specific soil testing limits. Why do we rely on a phosphate limit that was done 30 years ago at GRDC for your farm up the road here? You don't know that it's exactly the same. So what is my critical phosphate threshold for this farm? You don't know. You're just going off that, we need to be above 20. Is that true or not? You don't know. So why don't we run, every paddock should have its own critical thresholds for soil testing, for soil levels. We just never built it yet, but that's what you're talking about. It's like, what is it for my property? What's the limit that I need to be at? And what has that led to in the past? If we run a strip of phosphate through, we get no response. Well, you say, well, actually, our critical levels are different to what it was at GRDC. So I think what you point out is a perfect example. It's about building that knowledge base about your property and what responds where and what's important for that particular soil type combination. And even when you talk about things like plant counts, like wheat's a great example, right? Great example. If I'm at Gundawindi and I have an EM map that looks like what we had there, right? First thing I do is say increase the seeding rates on these areas. Why? Because they're not tillering as much and you've got low ground cover. So all we do is up the seeding rate. Try and get more ground cover. So what is the critical seeding rate for that piece and that piece? So forget even your general recommended establishment rates for cotton in wherever. I need to know now at a subfield level what's the ideal seeding rates. And so now we're doing seeding rate trials on top of phosphate trials to work out what is that combination for exactly my particular soil mix going forward. What rate of wheat seed should I be applying? And yesterday we heard at the Grenfell update they're fine-tuning canola rates for their exact property as well because they're trying to cut down cost. Seed's got real cheap now, isn't it? Canola seed, sorghum seed, corn seed, very expensive. So what is the seeding rate that I need that's going to best optimise my yields in my zones, not just my farm or paddocks, my zone? What's the optimal seeding rate? And you can do all that. Don't need a research station. Just use your farm. Run trials, you can put them in with variable rate, you can measure the results with your yield monitor, and you got your answer. Some more questions?
Efforts underway. Like, so one of the original promises with going to the NVT system was that we'd have more data, much more data that we'd had, that would be consolidated, and the ability to explore that data set, you know, performance of different varieties under different soil properties, P levels, disease pressure, and to my knowledge, that hasn't actually been mined ever in that way, because it becomes it's not the site specific that we're talking about here, but it's got some of the agronomic principles that show us the value of knowing this measurement versus that yield, because we've got the plot yield.
Yes.
Like, is there any thoughts or GRDC looking at how that sort of existing data set can help inform and understand some of the value when you're saying, well, you know, what does plant population do to yield over huge, you know, areas? Well, NVT could start to unlock that, because we've got years and years and years of data.
Yes.
You know, 1.8 metre plots.
Yes, and I know, NVT still gets a very big presence in GRDC, so I probably can't answer the question because I don't really know, but I know there's a lot of effort still put into NVT.
But they don't bring, you know, I think,
to mine it.
evaluate varieties, but
Yep.
we don't
Mine the data.
economic information. I think it could
Yep.
show it. So to me, I think that'd be one of the avenues to just help road test what is the variability, and maybe even provide some of the parameters on
Yes.
where there is high value there to look at for the data side.
Yeah, 100%. And it's getting easier to do that with the power of processing data. It's getting easier. We just need someone to do it and ask the questions of the data set.
I think the frustrating thing is that there's been so much effort put into the aggregating it. You know, like the on-farm trials database, and
Yes.
aggregate it.
Let's disaggregate it.
But nobody's doing anything with it.
Yeah.
That's the issue. So it's been less money aggregating it and stuff that would be
More money mining it.
mining
Yep.
stuff that's there.
Yep. No, I agree. 100%. Any other comments, questions?
How good is your current identification through your drone?
You know, probably ask John after this about what he thinks about it, but certainly the way that I describe it is that if you can see a difference when it's standing on the back of your ute for the thing that you're looking for, then we'll probably be able to identify it. Now, the economics of that varies dramatically though. So if, let's say we're collecting 1 centimetre pixels, which is sort of a reasonable standard for what drones collect. 1 centimetre, if we go to half a centimetre pixels, that's not twice as expensive for us to process, that's 4 times as expensive for us to process. So the economics of it is very rapidly changeable, but certainly we've found that if there's structural difference, there's colour difference, it's something that you can identify with your eye fairly simply from the back of the ute, then we'll be able to pinpoint it. Yeah. And so we went from like trying to build out specific algorithms for everything. We have a bunch of algorithms for stuff that we can do. Went from that to a broader computer vision, in inverted commas AI, so a computer vision solution that we could just adapt to almost anything, noting that like issues, and a single issue might manifest 1 year and not manifest for another 4 years, and I've got to make money in those intervening 3 years, you know what I mean? So we had to build a more flexible system for it, and currently the one we've got is pretty flexible.
The other thing that's different too that we're working on is that most drones will do RGB, red, green and blue, and near infrared, and maybe some mid. There is hyperspectral drones available, very expensive.
And so the drone in there, we have mainly use RGB. You can put multispectral and you can put hyperspectral, you can put LiDAR, you can put all sorts of things on it. That's the one reason we went for that versus the DJI one. The DJI one's just, the drone is part of the dock or whatever. That thing you can sling whatever you want almost off the bottom of it.
I guess the point about that is that our eyes can only see red, green and blue. We can't see infrared and beyond. The satellites that we're starting to work with too, the one at 10 metre that I showed before, it's got 8 different bands of light, the 3 that we can see, but plus a whole others that you can't. There's also companies we're talking to that have 500 bands of light. 500. So the spectrum, the differences between each little thing is going to become more evident, if that makes sense. The more slices of that pie I can cut up, the more chance I've got of... So your question about what can I see that's different, it might be something you can't even see. It's expressing other things that we can't even detect with our eyes, but we can detect with the sensor. So I think that's the really exciting bit. So we're using hyperspectral as part of the GRDC project to look for ryegrass and wheat. Something we can still see, but it's very similar. So I'm really comfortable that we should be able to get a sensor to pick that up, to really identify the differences, because it should stand out a lot clearer. Same thing we're doing with rust and in wheat. What sort of spectral signatures does it give just before it outbreaks with rust? What is the plant doing that we can't see? It could be thermal. You know, is the plant, like we did some work a couple of years back in sorghum lodging. We detected the parts that are lodged in the paddock 3 months before harvest. And the reason we picked them up is because the leaf was stressed. The leaf stopped using water. Started to separate between the good parts of the paddock and the lodged parts of the paddock way back 3 months before harvest, because it started to shut down, but it looked like a normal green plant, and then it fell over because of charcoal rot. So, you know, those are the kind of things that I'm hoping we can pick up that the plant's telling us before we actually see it ourselves. And that's, again, the exciting bit. You can hang these things under drones as well. It takes a mammoth amount more data to process though. So you're talking 1 centimetre to 5 millimetre pixel is a massive 4-step change. Times that by not 4 bands or 5 bands of light now, times that by 300 bands of light. You can see the enormity of the data processing. So some of these satellite companies are offering to sell us band by band. So we can pull out the bands that we want. So say we work out what rust looks like, it might be band 1 and 72 and 621, we'll just pull those bands out. So we only got to process 3 things now instead of 300. So that's the kind of work that's coming. That's the exciting bit about sensors beyond this as well.
Is there a potential, trying to look right above this, is there a potential for chaos theory to overrule your reductionist scientific approach? As in, you're going to look at one specific problem with your 3 light spectrum,
Yeah.
and you miss the problem altogether because it's just
It's a good point.
nature.
Yeah. Do we miss the wood for the trees? Yeah. Yeah. So, well,
Increase the cost of farmers
for no benefit. Yeah. Well, I think that's a very good question, and that's all of AI at the moment, isn't it? Like, are we doing ourselves in by all this technology? So I think it's horses for courses. If we're specifically targeting things, we might run 5 different models and say, look, we've got nothing on 4 of them, but this one here is showing something. But again, you can still keep that overarching view. Like, just basic NDVI imagery, as I've shown you, is a great starting point. And then we need to ask more questions of it. So it's a good point you make, though. You've got to be careful we don't miss the wood for the trees, for sure. Yeah.
Tim, I think one of the major balancing points will be accuracy versus repetition, and I think we're a bit on a pathway about much more accurate, higher resolution, whereas potentially what some of the advantages of this sort of system is economical repetition, and
Yep.
you get your accuracy because you don't fly it once a month, twice a year, you fly it once a week.
Yes.
And then you're looking at the change
Yep.
over time, and I think to me that's probably one of your best defences over being focused on one thing, because if you go for super accurate on 1 or 2 things, and it becomes so costly with the data and the analysis that you lose the repetition. That's when we get a bit blind.
Yep.
I think we will get blind. And
Good point.
this other thing.
Yep. I agree. That's a very good point. Cool. We'll go and have a look at this machine.